Okay, let's unpack this. You know how sometimes you look at a device, something as simple as a thermostat or, I don't know, a security camera, and you think, wow, this thing is getting surprisingly smart.
Uh,
It's learning, it's reacting. Sometimes it almost feels like it anticipates what I need. That feeling, that's the edge of something huge.
it really is. It's the transformation of, well, everyday objects, industrial machinery, entire transport systems, really,
Yeah.
the physical world around us by sort of infusing them with intelligence.
Right.
We're moving beyond just simple automation to, true autonomy and predictive capability.
Exactly. And today, this deep dive is dedicated to that exact thing, that powerful force reshaping our world, the AI-driven IoT revolution. We've
Mm.
got some fantastic source material guiding us today, a real deep dive itself into how artificial intelligence and the Internet of Things are converging, and what that actually means in practice.
Yeah, and it's important because it's not just like futuristic speculation, right?
No, it's happening now.
Yeah.
And our source material lays out the implications, backed by case studies and, outlining the emerging trends.
And this guide, it's particularly valuable because it really tries to cut through the hype. It focuses on the tangible impact.
Okay.
It's essential reading, or, well, in our case, essential listening, for anyone involved in building these systems, developers.
Right, the tech folks.
And absolutely crucial for technical management. People needing to make strategic decisions about, like, where to invest and how to deploy these technologies effectively.
And that's precisely our mission in this deep dive. We're going to break down the core ideas, try to extract the most important nuggets of knowledge from these sources, and give you a shortcut to really understanding this transformative convergence.
Hmm.
We're going to explore how AI dramatically enhances device capabilities, how it unlocks really powerful applications like predictive maintenance, how it impacts your smart home.
Which everyone can relate to.
Exactly, and even how it revolutionizes massive industrial operations.
And we'll also need to dig into the foundational stuff, right? Like robust data management, pervasive security, which is huge, and the role of edge computing.
Yeah, can't forget Edge.
Ultimately, we want to understand not just the technology itself, but its profound implications and, the path forward.
So are you ready? Let's jump into the fundamental concept first.
Okay, so what's truly transformative about this moment isn't just, connecting devices over here or developing smarter algorithms over there in isolation.
Right, it's the mix.
It's the synergy, the convergence of AI and IoT. Our source material highlights this right away. The core concept, laid out in the first chapter, is basically the integration of AI algorithms into IoT systems
Okay.
to enhance their functionality, turning these connect devices into truly smart devices.
So it's not just about a sensor collecting data and like sending it off somewhere. It's about that sensor being part of a system that can understand, analyze, and potentially even act on that data. Maybe right
Mhm.
there.
Precisely. The fundamental shift comes from giving the things in the Internet of Things a form of intelligence. And that intelligence, it's powered by AI, particularly machine learning.
Machine learning. Okay.
Think about the sheer volume of data. I mean, just imagine a network of IoT devices. The amount of data generated is astronomical.
Right. Every sensor reading, every camera feed, every little log entry, it's just this continuous massive stream.
Exactly. And traditionally, you might, collect that data, store it somewhere for later analysis, maybe run some reports, or set up simple threshold alerts.
Like if temperature goes above X, send an alarm, that kind of thing. Useful, but, well, limited.
Very limited. And the critical role of machine learning here is that it provides the, let's say, sophisticated tools needed to process, analyze, and derive deep, actionable insights from this flood of data, often in near real time.
Okay, so actionable insights. How does it go beyond those simple rules?
Well, instead of just reacting to a static threshold, machine learning models can identify really complex patterns, subtle anomalies, emerging trends within that data stream, things that are frankly impossible for humans or simple rule-based systems to catch.
Can you give us a clearer picture? Like what kind of insights are we talking about that go beyond if this, then that?
Certainly. Let's imagine a factory floor. Hundreds of sensors monitoring everything: machine vibration, motor temperature, energy use, production speed.
Okay, lots of data points.
Right. A simple rule might just flag a machine if its temperature spikes suddenly. But a machine learning model, it can analyze the combination of things, maybe a slight increase in vibration over here, a minor change in how much energy it's drawing, and subtle shifts in the sound it makes.
Okay, none of those might trigger a simple alarm on their own.
Exactly. But the ML model sees that pattern collectively and recognizes, hey, based on past data, this combination often means this specific component is likely to fail soon, maybe hours or even days in advance.
Wow. Okay, so it's finding the signal hidden in all the noise, identifying correlations across different streams that point to something meaningful.
That's a great way to put it, finding the signal in the noise. And this ability to analyze data so intelligently leads directly to another huge benefit, enabling real-time decision-making.
Right, the action part.
This is where the rubber meets the road, so to speak. In a traditional IoT setup, data from the edge of the device often has to travel all the way to a central cloud platform.
Yeah, for the heavy lifting, the analysis.
Right. And then a decision or a command has to be sent back to the device. That round trip introduces latency, delay.
And delay can be critical in lots of situations.
Absolutely critical. By integrating AI processing capabilities either directly into the device itself or maybe onto local gateways near the devices, which gets us into edge computing. We'll talk more about that later.
Okay.
The analysis can happen almost instantaneously, right there at or very near the source of the data.
So the device or the local system processes the sensor input, runs the AI logic, and makes a decision or takes an action immediately, without waiting for that trip to the cloud and back.
Precisely. So instead of sense, send, receive instruction, then react.
Yeah.
It's more like sense, analyze locally, react now.
That makes a huge difference.
Think about safety critical systems.
Yeah.
An autonomous vehicle spots an unexpected obstacle it needs to decide, brake, or swerve in milliseconds.
No time for cloud round trips there.
Absolutely not. Or a security camera detects a potential intruder. It needs to trigger an alarm or lock a door instantly. In industrial automation, a system detecting an anomaly that could lead to danger needs to shut down equipment immediately. Real-time decisions powered by local AI processing are fundamental to the speed, the responsiveness, and ultimately the safety and autonomy of these systems.
It gives these devices a kind of independent intelligence, maybe, to react to their immediate environment guided by what they've learned.
That's a good way to think about it, guided by learned patterns.
Our source material mentions that successful AI IoT integrations are already widespread. Can we make these a bit more concrete? Maybe some examples.
Sure. Well, the source gives a broad overview. It points to applications across different sectors. Let's take manufacturing. Imagine an AI-powered vision system on a high-speed production line.
Okay, cameras watching the products go by.
Right. It can analyze images of every single product instantaneously, comparing it against quality standards. It spots tiny defects immediately. That's way faster, way more consistent than human inspection.
And it allows for real-time adjustments.
Exactly.
Yeah.
Maybe adjust something earlier in the line if it starts seeing a pattern of defects, or think about agriculture, that irrigation example.
Yeah, the smart watering system.
An AI-driven system with soil moisture, temperature, weather sensors. It's not just reporting data. It's analyzing all those inputs right there at the edge for a specific section of the field.
Understanding the microclimate, almost.
Precisely. And the plant's needs. And it decides, in real time, okay, activate the irrigation just for this specific patch because the AI has determined it needs water right now, maybe factoring in the forecast too.
That's intelligence driving immediate, very localized action, not just watering the whole field on a timer.
Right. These examples show how this convergence fundamentally changes what connected devices can do. They shift from being passive data collectors to active, intelligent agents.
Yeah, it really raises an important question, doesn't it? Beyond just faster processing, what fundamentally new things can these AI-powered systems do that were just, well, impossible for traditional IoT?
It feels like it unlocks the potential for true autonomy, maybe, and optimized resource management in ways we only sort of dreamed about before.
Yeah, moving from a network of control devices to maybe a network of intelligent participants.
That's a key phrase.
Yeah.
Intelligent participants. It's about building systems that can perceive their environment, understand the context through data analysis, and make optimal decisions to achieve a goal.
Okay, that lays a really solid foundation. Now let's dig into one of the most impactful applications of this AI-IoT synergy, which is covered in Chapter 2 of the source. Predictive maintenance.
Yes, this is a big one.
This is where that intelligence translates directly into preventing problems, saving money, avoiding headaches.
Absolutely. Predictive maintenance is, well, a prime example of AI and IoT working together to deliver really significant operational benefits. The core idea basically is to move away from reactive maintenance.
Fixing things after they break. The worst time.
Exactly. And even scheduled maintenance. Fixing things at fixed intervals, which can be wasteful if it's not needed or too late if it is.
Right, that change the oil every 3,000 miles approach, whether it needs it or not.
Kind of like that. Predictive maintenance shifts to a proactive, data-driven approach that predicts potential equipment failures before they actually happen.
So instead of waiting for the machine to die or replacing parts just because the calendar says so, the system tells you, hey, this specific bearing is showing signs it might fail in the next 2 weeks. You should probably schedule a replacement.
That's exactly it. And the how starts with all those IoT sensors deployed on critical assets. They're continuously collecting detailed performance data.
Like what kind of data?
Oh, things like vibration levels, temperature fluctuations, acoustic signatures, the sounds the machine makes, how much electrical current it's drawing, rotational speed, pressure, how many cycles it's run, even visual data from cameras or chemical analysis in some cases. They are the constant eyes and ears on the equipment's health.
That is a lot of data pouring in constantly.
It is, and that's where the AI comes in to make sense of it all.
Right, back to the machine learning.
Precisely. AI algorithms, particularly machine learning models trained for anomaly detection and time series analysis, they process this torrent of sensor data. They compare the real-time data against established baselines for healthy operation.
What normal looks like.
Right, what normal looks like. And they also compare it against historical data that includes records of past failures. So the AI learns to identify these subtle deviations or specific patterns in the data stream that are known precursors to certain types of failures.
So it's like the AI learns the machine's normal heartbeat, maybe, and it can detect even a faint arrhythmia long before a human would notice anything wrong.
That's a really good analogy. The AI can correlate changes across multiple sensor readings. Maybe a slight temperature increase combined with a specific frequency change in vibration, for example.
Okay.
Together, those might indicate developing wear or damage to a component, even if no single reading is technically outside a standard threshold yet. It spots those faint early warning signs that are often invisible to human operators or traditional monitoring.
The ability to catch those subtle indicators must have huge economic benefits. Our source really emphasizes cost savings and efficiency improvements. Can we get more specific about those?
Oh, the economic advantages are compelling. First off, reduced downtime. That's massive. Unexpected equipment failure can be incredibly costly.
Especially in manufacturing.
Exactly. A breakdown on a critical production line in a big factory. It could cost tens, even hundreds of thousands of dollars per hour in lost output.
Wow.
By predicting the failure, maintenance can be scheduled during planned downtime, maybe overnight, or on a weekend, or during a pre-scheduled maintenance window. You completely avoid, or at least minimize, the impact of that unexpected stop.
So you avoid that sudden, chaotic scramble to fix a broken machine while everything else grinds to a halt. Makes sense.
Exactly. Second, maintenance costs themselves are often lower. Repairing or replacing a component that's showing early signs of wear is typically much less expensive than dealing with a catastrophic failure.
Where one part breaking takes out several others.
Right. You might damage multiple interconnected parts in a big failure. You're fixing a developing issue, not cleaning up a wreckage after the fact.
It's like replacing a worn tire before it blows out at 70 miles per hour and causes a crash, damaging a whole car.
That's a very apt comparison. Third, predictive maintenance helps extend the lifespan of valuable assets. By proactively addressing issues based on the equipment's actual condition, you prevent unnecessary wear and tear from minor problems escalating. This lets the machinery operate reliably for longer before needing a costly replacement.
Okay, so better asset utilization.
Yep. And finally, you achieve optimized maintenance scheduling. Instead of sticking to rigid time-based schedules like replace part X every 1,000 hours, remember?
Yeah.
Maintenance is performed only when the AI analysis indicates it's actually needed. This prevents wasting resources, time, and money on unnecessary maintenance, while ensuring that maintenance is performed promptly when the data demands it.
It just sounds like a much smarter, more resource-efficient way to manage valuable assets. And those efficiency gains, they translate directly into bottom-line improvements for industries relying on heavy machinery or complex infrastructure.
Absolutely.
Our source illustrates this with real-world examples in manufacturing and transport. Let's try and paint a picture of those.
Okay, in manufacturing, let's consider a crucial industrial robot in, say, a car assembly plant. It's doing highly repetitive, precise tasks constantly.
Right, working 24/7 almost.
Exactly. Sensors on its joints, motors, power supply, they feed data continuously. The AI system monitors vibration frequencies, motor current profiles, temperature trends. Now, the AI might detect a slight but very specific increase in high-frequency vibration in one particular joint.
Okay, just a subtle change.
Right, and maybe it's coupled with a minor increase in motor temperature when under load. Based on its training data from thousands of similar robots and historical failures, the AI predicts that the bearing in that specific joint is degraded and likely to fail within, say, the next 72 hours.
Wow, that specific.
It can be. So an alert goes to the maintenance team. They can then schedule the robot for repair during the planned overnight shutdown. They replace just the bearing, maybe costing a few $100s, and completely prevent an unscheduled breakdown during peak production hours that could have cost thousands or tens of thousands in lost output.
That level of precision and foresight is just, yeah, it's game-changing. And what about in transport?
Think about rail transport. A train engine is an incredibly complex piece of machinery operating under really demanding conditions.
Oh, sure.
IoT sensors throughout the engine collect vast amounts of data in engine temperature, oil pressure, fuel injection performance, wheel bearing temperature and acoustics, brake system pressure, you name it. An AI system analyzes this data stream from every engine in the fleet.
Okay.
It might detect a subtle but growing anomaly in the acoustic signature, the sound of a specific wheel bearing on one particular train, even though the temperature isn't critically high yet.
So it hears something wrong before it overheats.
Exactly. The AI's model, trained on historical data, identifies this specific sound profile as a strong indicator of developing bearing failure. So the system alerts the maintenance depot. They schedule that train for wheel inspection and bearing replacement at its next scheduled stop, or maybe during a less critical part of its journey.
Long before the bearing actually fails and causes a trackside breakdown.
Right, a breakdown that would delay thousands of passengers and disrupt the entire rail network.
These are incredibly compelling examples. It really shows how the seemingly dry world of sensor data, when you power it with intelligent AI analysis, can proactively prevent major disruptions and save significant resources.
It truly embodies that shift we talked about,
Yeah.
from fixing problems to preventing them entirely.
It is a major leap forward. Okay, let's shift our focus now from heavy industry to a realm many of us interact with every single day, our homes. Chapter 3 of our source material delves into the innovations happening in smart homes driven by AI and IoT.
Yeah, this is maybe the most tangible application for the average person listening.
Yeah.
And we've seen, remarkable evolution in this space just recently.
It really feels like just a few years ago, smart home meant, being able to turn on a light with your phone app.
Right, basic remote control.
Now it seems much more integrated and, well, responsive, almost like the house knows things.
Absolutely. Smart home devices have moved way beyond simple remote control. We now have this whole ecosystem of connected devices, right? Smart thermostats, lighting systems, security cameras, door locks, smart speakers, connected appliances, voice assistants.
The list goes on.
It does. But the real intelligence comes from integrating AI into these systems. This moves them from being just remotely controllable gadgets to systems that can learn, adapt, and personalize the home environment.
How does AI enable that level of personalization? What's it actually doing?
Well, AI allows the smart home system to learn the habits, preferences, and patterns of the people living there. This learning then informs autonomous adjustments to optimize comfort, convenience, and even efficiency, often without needing constant manual input from you.
Can you give us some specific examples of this personalization in action?
Sure. Take a smart thermostat with AI capability. It can learn your daily and weekly schedule, not just when you typically arrive home, but maybe it factors in how quickly your house loses or gains heat based on the outside weather.
Ah, so it's smarter than just a timer.
Exactly. And it preconditions the house to the temperature you like just before you arrive. It can also learn specific preferences, like maybe you like it slightly warmer in the morning.
So it anticipates your needs based on learned behavior and environmental factors, rather than just a rigid schedule you programmed once.
Precisely. Or smart lighting systems. They can use AI to learn how you use different rooms at different times of day and adjust the brightness and even the color temperature automatically.
Like bright, cool light for working in the kitchen, maybe warm, dim light in the evening in the living room.
Exactly that kind of thing. AI-powered security cameras can learn to recognize family members, pets, or frequent visitors.
Okay, so fewer annoying alerts when the cat walks by.
Right. Reducing false alerts and notifying you only about genuinely unfamiliar activity or maybe recognizing expected visitors like delivery drivers.
And we hear about smart appliances doing more than just their basic function, too, right?
Yes, definitely. A smart oven with AI might learn your cooking preferences for different types of food and suggest optimal cooking times and temperatures based on past results you liked.
Hmm, interesting.
Or a smart refrigerator with internal cameras and AI object recognition. It could help track what food you have, maybe suggest recipes based on the ingredients it actually sees inside,
Okay, that's pretty advanced.
and even alert you when commonly used items like milk or eggs are running low. This personalization just makes the home feel more intuitive, more responsive, and it can lead to real energy savings too by optimizing usage based on actual occupancy and habits.
All of that sounds incredibly convenient, almost futuristic. But the flip side of having so many connected devices listening, watching, learning in our most private space has to be security and privacy. Our source highlights this as a critical challenge.
It is an absolutely paramount concern. You have to think, every single connected device in your home, from a simple smart plug to a complex security system, represents a potential entry point for cyber threats.
The attack surface just grows with every device you add.
It expands dramatically.
So, what are the specific risks homeowners should be aware of? What could actually happen?
Well, the risks are varied, and they're serious. There are data privacy concerns, obviously. Imagine hackers gaining access to sensitive data about your daily routine, your energy usage patterns, maybe even audio feeds from voice assistants.
That's unsettling.
Then there's the risk of unauthorized access to your home network itself. If they get in through a vulnerable smart bulb, they could potentially use that to launch attack on other devices on your network, like your computer, or steal personal information.
And then there are the physical security risks too, right?
Absolutely. If smart locks, garage door openers, or alarm systems are compromised, that could potentially allow unauthorized physical access to your home.
That's a really disturbing thought. Our source implies that solutions are actively being developed to tackle these issues. What direction are these solutions heading in?
Well, while the source doesn't give exhaustive technical details, the implication is a strong focus on building security and privacy into the design from the very beginning, not adding it on later.
Security by design.
Exactly. This includes things like implementing strong encryption for all data transmitted between devices and the cloud, developing more robust authentication mechanisms, making sure only legitimate devices and users can access the network and data, and potentially exploring strategies like network segmentation.
What's that?
Basically, isolating your smart home devices on a separate part of your network, away from more sensitive things like your personal computers or financial data.
Ah, okay, like putting them in their own little sandbox.
Kind of. And of course, regular, easy-to-apply software and firmware updates are crucial for patching vulnerabilities, though that's often a challenge for consumers to manage consistently across dozens of different devices from different brands.
Yeah, keeping everything updated is tough. It's clear that as our homes get smarter, balancing that incredible convenience with robust privacy and security measures is a critical challenge. Manufacturers and us, the consumers, both need to prioritize it.
Absolutely. And if we connect this back to the bigger picture, the security and privacy challenges faced in the smart home, they're actually illustrative, just on a smaller scale, of the even more complex and, frankly, higher stakes challenges faced in industrial or critical infrastructure AI/IoT deployments.
The principles are similar, but the potential consequences of failure are much, much greater in those environments.
Precisely.
Speaking of that grander scale, let's transition now to Chapter 4, which digs into the transformative impact of AI-integrated IoT in large-scale industrial settings, what's commonly known as industrial IoT or IIoT.
Right. This is where the convergence of AI and IoT has the potential to unlock truly massive gains in operational efficiency, productivity, and safety across entire industries. Think manufacturing, energy, logistics, mining.
Okay, so how is IIoT fundamentally changing those traditional industrial practices? What did things look like before, and what do they look like now with IIoT in the picture?
Historically, industrial operations, like big factories or processing plants, were often characterized by, well, manual processes, disconnected machinery, and data silos.
Information stuck in different places, not connected.
Exactly. Operators relied on periodic inspections, maybe handwritten logs, isolated control systems for different parts of the plant. Visibility into the end-to-end process was often limited, relying on reports compiled, after the fact. This made it really difficult to react quickly to problems, optimize performance dynamically, or predict issues before they impacted production.
That sounds like a lot of isolated systems and delayed information flow, not very agile.
Not at all.
Yeah.
The transformation brought by IoT is profound. It involves deploying these vast networks of connected sensors, machines, and systems across the entire industrial environment.
Connecting everything up.
Right. This creates a continuous, real-time stream of data about pretty much every aspect of the operation, from the performance of individual components on a machine, to the flow of materials through the plant, to energy consumption patterns. Then, AI systems analyze this immense data stream
To do what?
to provide real-time monitoring, predictive insights, like we discussed with predictive maintenance, and enable automated intelligent control and optimization across the board.
What does this transformation enable in terms of practical applications within, say, a factory setting? What can they do now that they couldn't before?
Well, our source highlights several key areas. One is optimizing production lines. By collecting data from sensors on conveyors, robotic arms, assembly stations, quality control checks, AI can monitor the entire flow.
See the whole picture in real time.
Yes. And it can detect bottlenecks as they start to form, predict potential slowdowns based on current conditions, and even dynamically adjust the speed or coordination of machines on the line to maintain optimal throughput, minimizing idle time, and maximizing output.
So the production line becomes a kind of dynamic, self-optimizing system rather than just a fixed sequence of operations moving at a set speed.
Precisely. Quality control is also revolutionized. We touched on this, but high-definition cameras combined with AI vision systems can perform automated inspections on every single product as it moves down the line.
Much faster than humans can.
And with incredible consistency. They can identify defects far surpassing human capability, especially at high volumes. This allows for immediate identification and removal of faulty products, and it provides real-time feedback to earlier stages of production to identify and correct the root cause of those defects quickly.
And given the huge energy demands of heavy industry, energy management must be a major focus area for IoT too.
Absolutely. IoT sensors can monitor energy consumption right down to the individual machine level or subsystem level and facility-wide. AI analyzes this data to identify areas of excessive consumption or waste.
Find the energy hogs.
Exactly. It can predict peak demand periods and optimize energy usage by, say, scheduling energy-intensive tasks during off-peak hours when electricity might be cheaper, or by dynamically adjusting system operations slightly without compromising production targets. This can lead to significant cost savings and also improve sustainability.
Makes sense. Any other examples?
Oh yeah, things like enhanced asset tracking for materials and tools using RFID or other sensors, environmental monitoring within the plant, and even worker safety monitoring using wearables or cameras with AI analysis.
This sounds incredibly powerful, almost like a factory with a central nervous system and a brain. But it must also come with significant complexity. Our source points out some key challenges organizations face during IoT integration.
Oh, the challenges are definitely substantial, and they can really slow down adoption. One of the biggest hurdles is integrating legacy systems.
The old stuff.
Right. Many industrial facilities have existing machinery and control systems that are decades old. They were built on proprietary protocols, never designed to connect and communicate with modern digital technologies. Integrating these old systems with new IoT sensors and AI platforms is technically complex, it's time-consuming, and it can be very expensive. It's definitely not just a matter of plug and play.
So getting that brand new smart sensor to actually talk meaningfully to the 30-year-old, but still vital piece of machinery is a major headache.
It's a huge headache. Another challenge is just the sheer scale and complexity of deploying and managing a vast interconnected network. We're talking potentially thousands, even millions of devices and sensors across a large industrial site or multiple sites.
Wow.
This requires sophisticated network infrastructure, robust device management platforms, and ongoing maintenance. And ensuring interoperability, making sure equipment and software from different vendors can actually work together, that remains a persistent challenge, despite ongoing efforts towards standardization.
And the data scale we keep mentioning that must be particularly daunting in IoT environments.
It is. The volume, velocity, and variety of data generated by IoT are just immense. Managing this data, effectively storing it securely, processing it efficiently, making it accessible for AI analysis in a timely manner, is a significant technical and logistical challenge in itself.
And I guess finding people with the right skills is also tough.
Absolutely. There's the challenge of the workforce, which we'll dig into more later, but IoT requires specialized skills that are currently in very high demand and relatively short supply.
What's truly fascinating here, though, is the scale of the ambition and the potential impact. IoT isn't just like an optimization layer you add on top. It represents a fundamental shift in how entire industries operate, moving towards highly automated, data-driven, intelligent
That
systems.
really does.
This is why some people refer to it as a cornerstone of the fourth industrial revolution, right?
It is indeed a paradigm shift. And if we connect this to the bigger picture, successfully navigating these integration challenges, the technical ones, the data-related ones, and the human ones, is absolutely paramount for companies to realize the immense potential of IoT and maintain or gain a competitive advantage in the modern industrial landscape.
That leads us perfectly into Chapter 5, which addresses a topic that becomes exponentially more critical with the scale of data and connectivity we're seeing in AI IoT, enhanced data management and security.
Right. As we've kind of highlighted throughout, these AI IoT systems generate unprecedented volumes of data. This data is the fuel for the AI. It's essential. But managing it and securing it effectively is a monumental task that organizations absolutely must get right.
So why is robust data management, specifically something called data governance, why is that so vital in these interconnected AI IoT environments? Sounds a bit bureaucratic.
Well, it might sound bureaucratic, but think about it. With data streaming continuously from potentially millions of devices scattered across different locations, coming in various formats, and being used for everything from immediate operational decisions to long-term strategic planning, you need a clear framework for how that data is handled.
Okay, brings order to the chaos.
Exactly. Data governance provides the rules, the processes, the accountability structures for collecting data, storing it, processing it, accessing it, and ultimately using it.
So what does that involve practically?
Key aspects include things like defining data ownership, who is actually responsible for the data coming from which devices, ensuring data quality and accuracy because, garbage in, garbage out applies even more strongly when AI is making decisions based on that data.
Right, the AI needs good data to learn properly.
Absolutely. Establishing data retention policies. How long do you actually need to keep this potentially massive amount of data? What are the legal or operational requirements for keeping it and for disposing of it securely? And defining data access controls who gets to see and use which data and under what conditions.
Okay, so control and process.
Right. Effective data governance ensures the data is reliable enough for AI analysis, that it's compliant with regulations, which we'll get to, and that it's used responsibly to derive value while mitigating privacy and security risks. Without it, you risk fragmented data, unreliable insights from your AI, and potentially significant legal or reputational exposure.
And alongside managing the data is the absolutely critical element of securing it. Our source really stresses the significance of cybersecurity in all AI IoT solutions.
And rightly so. We touched on this with smart homes and IoT, but it bears repeating. The attack surface for cyber threats just explodes in AI IoT deployments. Every single connected device, every sensor, every gateway, every network segment, every cloud service, every application layer. It's a potential vulnerability that attackers can try to exploit.
And the consequences of a breach, as we discussed, can range from significant financial loss to operational paralysis or even real physical danger in industrial settings.
Precisely. In IoT, a compromised system could lead to damaged equipment, environmental incidents, or serious safety hazards for workers. In critical infrastructure like power grids or water systems, the risks are even higher. Therefore, cybersecurity cannot be an afterthought. It just can't. It has to be integrated into the design of AI IoT systems right from the very beginning.
So what does that mean in practice? What are the layers of security needed?
It means implementing robust security measures at every single layer. Securing the physical devices themselves, preventing tampering, ensuring they boot up securely, securing the communication channels using strong encryption, secure network protocols, implementing strict authentication and authorization mechanisms, making sure only legitimate devices and users can connect and access data, constantly monitoring networks or systems for threats or anomalies, and even ensuring the AI models themselves are resilient against attacks designed to manipulate their decisions or steal the model itself.
Wow, it's security everywhere.
It has to be.
And managing all this data and ensuring this level of security brings organizations face to face with some really complex compliance challenges, doesn't it?
Absolutely. Navigating the regulatory landscape is a major headache for businesses deploying AI IoT solutions, especially if they operate internationally or across different industries.
Yeah.
While our source doesn't list every specific regulation because they change so fast, it definitely highlights the challenge of complying with this complex web of rules.
What kind of rules are we talking about?
Well, things like data privacy regulations, which we mentioned GDPR in Europe, CCPA in California, and others popping up globally, These govern how personal data collected by connected devices must be handled.
And even seemingly technical sensor data can become personal if it's linked back to an individual or their activities, right?
Exactly right. Then there are industry-specific regulations. Healthcare has HIBIA governing patient data. Energy has regulations around securing grid infrastructure. Manufacturing has safety and data integrity standards. The complexity comes from trying to ensure consistent compliance across this vast distributed dynamic infrastructure involving many different devices, networks, cloud services, all potentially subject to overlapping or even conflicting rules depending on where the data originates, where it's processed, and where the users are.
This raises a really important practical question. How can organizations possibly manage these enormous volumes of data effectively, secure their systems against increasingly sophisticated threats, and navigate this complex and evolving regulatory environment, all while still trying to leverage the technology to gain value and drive innovation? It sounds almost impossible.
It's definitely a multifaceted challenge. There's no single silver bullet. It requires a holistic strategy that brings together technology, clear policies, robust processes, and trained people.
Okay.
What's fascinating here, and what the source implies, is that data management and security in the AI IoT era aren't just technical functions you can delegate solely to the IT department anymore. They are core business challenges that require strategic leadership, significant investment, and attention from across the entire organization. Success really hinges on treating data as a critical strategic asset and security as a foundational non-negotiable requirement, not just some optional add-on you bolt on at the end.
That makes a lot of sense. Okay, moving on. Chapter 6 introduces a concept that's becoming increasingly vital to making AI IoT practical and scalable, particularly for those real-time applications we keep talking about. Edge computing.
Ah, yes, edge computing. This is fundamentally about distributed processing. It's kind of the opposite of sending everything to the central cloud.
Okay, so what does it mean?
Instead of sending all the data generated by IoT devices way back to a central data center or a big cloud platform for processing and analysis, edge computing pushes compute capabilities closer to the edge of the network, closer to where the data is actually being generated.
So processing happens on the device itself or nearby.
It could be on the device itself if it has enough power, or on a local gateway device nearby, or maybe on a small server located on site, like in the factory or the office building. The key is it's close to the data source.
Why is this closer processing so important for AI IoT solutions? What are the main benefits of analyzing data right there, near the source, instead of in the cloud?
There are several really crucial advantages. The first, and maybe the most compelling for many applications, is significantly reduced latency.
Fast response times.
Much faster. For scenarios needing immediate responses, think autonomous vehicles again, or real-time industrial control loops, or critical safety systems. The delay involved in sending data to a distant cloud, waiting for it to be processed, and then sending a command back is simply unacceptable. It's too slow.
Right. Milliseconds matter.
They absolutely do. Processing data at the edge allows decisions to be made in milliseconds, sometimes even microseconds. It enables true real-time reaction.
Okay, so this links back directly to our earlier discussion about enabling real-time decision-making. Edge computing is often the how behind making that possible.
Precisely, is what makes those instantaneous responses feasible in many cases. Secondly, edge computing can dramatically reduce bandwidth usage.
How so?
Well, think about it. IoT devices can generate a fire hose of raw data, high-resolution video from security cameras, continuous high-frequency sensor readings from industrial machinery, just tons of data.
Right.
Not all of this raw data necessarily needs to be transmitted all the way to the cloud. Edge devices or gateways can perform initial processing locally. They can filter out noise, aggregate data points, compress the data, or even run AI analysis right there.
Okay.
And then they only need to send summary data or critical insights or specific alerts up to the cloud. This saves a significant amount of network bandwidth and reduces the associated communication costs, especially in locations where connectivity might be expensive or limited, like cellular data plans or satellite links.
So instead of streaming hours of security video, the Edge AI just analyzes it locally and sends a small alert that says, human detected in restricted area at 2:47 p.m. Much more efficient.
Exactly. Much, much more efficient. Thirdly, edge computing improves reliability.
How does that work?
Well, if the connection to the central cloud or data center is intermittent, unreliable, or maybe it goes down completely,
Which happens.
which definitely happens, systems relying on edge processing can often continue to function autonomously, at least for their core tasks, based on their local data and the AI models running right there.
Okay, so they don't just stop working if the internet connection drops.
Right. This is critical for things like remote industrial sites, maybe infrastructure in areas with poor connectivity, or any application where continuous operation is essential, regardless of the network conditions. It maintains a degree of operational independence.
That makes sense. Any other benefits?
And finally, edge processing can enhance privacy and security, although this depends heavily on how it's implemented. By processing sensitive data locally and potentially anonymizing or aggregating it before it even leaves the edge device or gateway, organizations can reduce the amount of raw, sensitive information that needs to travel over networks and be stored in the cloud. This can potentially lower the exposure to breaches during transmission or in cloud storage.
Our source mentions use cases that really highlight these improvements. Can we make those benefits even more concrete with some examples?
Sure, let's go back to autonomous vehicles. The sensors, cameras, LiDAR, radar generate terabytes of data per hour, processing all of that in the cloud in real time for driving decisions. It's just currently impossible because of the latency and bandwidth limitations.
Yeah, the car needs to react instantly.
Exactly. So the AI inference, the actual running of the AI models for object detection, path planning, decision-making, must happen on powerful processors right inside the vehicle. At the absolute edge, the low latency is non-negotiable for safety.
Okay, that's the perfect example of needing that instant response. What about bandwidth?
Okay, think about manufacturing quality control using those AI vision systems again. Deploying the AI models on edge servers or maybe directly on high-speed cameras right there on the factory floor allows for instantaneous inspection of products as they fly by.
Right, immediate feedback.
Yes, immediate feedback for process control adjustments. And, crucially, it avoids having to send massive volumes of high-definition video data over the factory network to some central server for analysis. That saves a ton of bandwidth and reduces the need for expensive network infrastructure upgrades.
And for reliability, when the connection might be flaky.
Think of remote infrastructure monitoring. Maybe oil and gas pipelines stretching through remote areas or mining operations far from reliable networks. Connectivity back to the corporate cloud might be sporadic, maybe only via satellite links sometimes.
Okay.
Deploying edge gateways with AI capabilities allows them to monitor things like pipeline pressure, flow rates, or mining equipment performance locally in real time. The AI can perform predictive maintenance analysis right there, detect anomalies, and trigger local alerts or safety shutdowns, even if the connection to the central monitoring facility is temporarily down.
So it keeps working, even when offline.
Right. Then, only summary data or critical alerts need to be sent back to the central system when connectivity becomes available again.
These examples really drive home why edge computing is often a necessary component for unleashing the full potential of AI and IoT, especially for this demanding applications. Our source hints at future trends in edge AI. What might that landscape look like going forward?
Well, building on these benefits, we can probably expect several trends to accelerate. We'll definitely see the continued development of more powerful, but also more energy-efficient, specialized AI chips. Chips designed specifically for deployment at the edge, right on the devices or in small gateways.
So smarter chips for the edge.
Exactly. There will likely be increased development of sophisticated software frameworks to help manage, deploy, and update AI models running on potentially thousands or even millions of these distributed edge devices. That's a big challenge.
Managing all that distributed intelligence.
Right. We'll also see more complex AI models being optimized and compressed cleverly so they can run effectively even within the limited compute power and energy budgets of edge hardware. The intelligence itself will become even more distributed, more capable, right out there at the edge.
What's really fascinating here is how edge computing isn't just, an infrastructure choice, it's really an enabler. It gives devices and local systems the power to perceive, analyze, and act with a speed and independence that just wasn't previously possible on a wide scale.
It absolutely is. And if we connect this to the bigger picture, edge computing is becoming pretty much indispensable for scaling AI IoT deployments effectively across all sorts of diverse environments, from smart cities and industrial facilities right down to consumer devices. It helps overcome those fundamental challenges of latency, bandwidth, reliability, and sometimes even privacy that you face if you try to rely solely on centralized cloud processing for everything.
Okay, so we've explored the technology, the applications, the data challenges, the infrastructure like edge computing. Now let's turn to a fundamental element without which none of this is possible: the people. Chapter 7 focuses on building the workforce needed for this AI IoT future.
Yeah, this is such a critical piece of the puzzle.
Mm.
Organizations just cannot afford to ignore the human element here. The rapid adoption and, frankly, the constant evolution of AI and IoT technologies require a workforce with a significantly different and, importantly, continuously evolving skill set compared to traditional IT or operational roles.
What specific skills gaps are organizations typically encountering as they try to actually implement and manage these AI IoT solutions? Where are they finding it hard to hire?
Well, the skills required are pretty diverse, and they often overlap. Organizations clearly need people with deep expertise in AI and machine learning development folks who can actually build, train, and deploy the models that power the intelligence.
The AI specialists.
Right. They also desperately need data scientists who can manage, clean, analyze, and interpret these enormous volumes of often messy data generated by IoT systems. People who can extract valuable insights and feed them effectively into the AI models.
So not just generic data analysts, but people who really understand the unique challenges of IoT data, its volume, its speed, its often unstructured nature.
Exactly. Then you need IoT system architects and integration engineers. These are the people who can design, deploy, and manage these complex networks of devices, sensors, and gateways, and crucially, integrate them with existing legacy systems and cloud platforms.
The bridge builders, in a way?
Kind of. Cybersecurity expertise is paramount, of course, but specifically, skills related to securing embedded devices, industrial control systems, often called ICS, and the communication protocols commonly used in IoT and IoT environments. These often differ quite a bit from traditional enterprise IT security.
So specialized security skills.
Yes, and knowledge of data governance and compliance, particularly relevant to distributed data coming from connected devices, is also increasingly necessary.
These sound like highly specialized areas. Why do these skills gaps actually exist? Why is it so hard to find people?
Well, the primary reason is just the sheer speed of technological change. AI and IoT are relatively new fields, and they're evolving incredibly quickly. University programs and traditional corporate training pipelines simply haven't been able to keep pace with the sudden, huge demand for these specific hands-on skills.
The technology is moving faster than the education system.
Pretty much. There's a significant lag between the emergence of these technologies and the development of a sufficiently large and experienced talent pool ready to work with them.
Our source discusses solutions, mentioning training programs and resources. What types of initiatives are needed to try and bridge these skills gaps?
While the source doesn't prescribe specific programs, it definitely implies that a multi-pronged approach is essential. This includes bolstering formal education pathways, encouraging universities to develop and expand programs focused specifically on AI, data science, IoT engineering, and cyber-physical security.
Long-term fixes.
Right. But perhaps more immediately impactful for the existing workforce are professional development initiatives. Things like targeted online courses, technical certifications offered by the big technology vendors, cloud providers, hardware manufacturers, and also robust internal company training programs designed to upskill current employees who might be in related fields, like traditional IT or operations.
Retraining the people you already have.
Exactly. And partnerships with technology providers who offer training on their specific platforms and tools can also be really valuable. The key underlying principle here is embracing continuous learning as just a fundamental requirement, both for individuals and for organizations wanting to stay competitive.
So it's not like a one-time training event and you're done. It's about building a culture of ongoing learning and adaptation because the tech keeps changing.
Absolutely. And speaking of culture, the source also rightly emphasizes the importance of fostering an innovation-driven culture within organizations.
Why is the organizational culture itself so critical for the successful adoption and leverage of AI and IoT? It's not just about the tech skills.
No, not at all. AI and IoT aren't just technologies you install like a new piece of software. They fundamentally change how operations work, how decisions get made, how data is perceived and valued across the company. A culture that is resistant to change, maybe overly risk-averse, or has traditionally siloed departments that don't collaborate well, that kind of culture will really struggle to integrate these complex, cross-functional technologies effectively.
It gets stuck.
It gets stuck. An innovation-driven culture, on the other hand, encourages experimentation. It embraces new ways of thinking. It values cross-departmental collaboration. It supports employees in learning new skills and gives them the space to apply them to solve real-world problems using these new tools. It basically creates an environment where people feel empowered to explore the potential of AI and IoT and integrate them creatively into processes.
It sounds like the technology itself can only be as successful as the environment, the human and cultural environment it's deployed within allows it to be.
That's a great way to put it.
This raises an important practical question then. Given the pace of change and the depth of the skills required, how can organizations and maybe individuals listening, how can they effectively prepare for and navigate these workforce challenges presented by the AI IoT revolution?
Well, it requires a proactive and strategic approach.
Huh.
For organizations, it means investing heavily, and I mean really investing in both external recruitment to bring in key expertise and in internal training and upskilling programs for their existing workforce.
Mhm.
It also means consciously working to cultivate that culture of innovation and collaboration we talked about.
And for
For
individuals.
individuals listening, it really means committing to lifelong learning. It means identifying the key skill areas that are driving these technologies: AI, data science, IoT, cybersecurity, edge computing, and actively seeking out opportunities, whether through formal courses, online learning, or on-the-job projects, to gain knowledge and practical experience in those areas. Staying curious and adaptable is key.
Makes sense. If we connect this to the bigger picture, the ultimate scale and success of this whole AI IoT transformation across industries is going to heavily depend on the ability of the global workforce to actually design, build, manage, and innovate with these intelligent connected systems.
The human element is absolutely the crucial enabler. You can have the best tech, but without the right people and culture, you won't realize its potential.
Okay, finally, let's turn to Chapter 8. This brings us to the broader context and the really critical considerations that inevitably accompany the immense power of AI and IoT, the regulatory and ethical considerations. These technologies don't operate in a vacuum, right? They have societal implications that demand very careful attention.
Absolutely. And this is arguably one of the most complex and rapidly evolving areas related to AI and IoT. While the source doesn't, and probably couldn't, provide an exhaustive list of every specific regulation, partly because the landscape is changing so fast globally, it definitely emphasizes that regulations exist and are being developed precisely because these technologies raise significant questions about privacy, security, fairness, and overall societal impact.
What are the main areas where regulations are currently impacting or are likely to impact AI and IoT implementations in the near future?
The source points to several key areas that are consistently the focus of regulatory attention around the world. Data privacy is paramount, building on existing laws like GDPR in Europe or CCPA in California and similar ones elsewhere.
We keep coming back to privacy.
Because it's fundamental. These regulations involve rules around how data collected by connected devices, which, as we've said, can be highly personal, tracking location, behavior, health metrics, conversations, how that data must be handled. There are requirements for getting proper consent, minimizing the data collected, being transparent about how it's used, and giving individuals rights to access or delete their data.
Okay, privacy rules. What else?
Device security standards are another growing area. Regulators are increasingly looking at mandating minimum security requirements for connected devices, especially consumer ones.
To try and prevent all those easily hackable smart gadgets from becoming a widespread vulnerability, like for botnets and stuff.
Exactly that, trying to raise the baseline security level. There are also evolving regulations related to safety, particularly in sectors like transportation, think autonomous vehicles, and industrial automation, ensuring that AI-powered systems meet really stringent safety standards before they're deployed widely.
Makes sense for safety critical stuff.
And perhaps the most complex area is the emerging discussion around regulations for AI decision-making itself. This gets into addressing thorny issues like algorithmic transparency. Can we understand why the AI made a certain decision? Fairness, is the AI discriminating against certain groups? And accountability, who is responsible if an AI system makes a harmful autonomous decision?
Wow, regulating the AI's decisions. That sounds incredibly difficult.
It is incredibly difficult.
Yeah.
And navigating this complex and constantly changing regulatory environment must be a huge challenge for businesses trying to innovate in this space.
It absolutely is. Organizations need to stay constantly informed about the relevant regulations in all the different countries and regions where they operate or where their devices might end up being used. Ensuring compliance across a globally distributed, highly dynamic AI IoT infrastructure is a significant legal and operational hurdle. And beyond the formal regulations, there are also significant ethical dilemmas raised by the pervasiveness of AI and IoT data collection and decision-making. Our source touches on these critical points too.
Yes, and these ethical considerations are absolutely fundamental, sometimes preceding or going beyond formal laws. One major dilemma revolves around the use of the vast amounts of data collected. With sensors potentially everywhere in our homes, our cars, public spaces, workplaces, an incredible amount of data about individuals and their activities is being generated constantly.
So the question is, how is all that data being used?
Exactly. Is it being used solely for the stated purpose that the user agreed to? Or is it being aggregated, analyzed, maybe sold or shared in ways that could be intrusive or completely unexpected by the individual? There are serious concerns about pervasive surveillance, the potential for misuse of highly personal data, and the possibility of this data being used to create incredibly detailed profiles that could lead to discriminatory practices in areas like insurance, employment, or credit.
That potential for surveillance and discriminatory profiling based on AI analysis of IoT data is a really serious ethical concern.
It is. Another major ethical area relates directly to that AI decision-making we mentioned. As AI systems become more autonomous, making decisions based on data, whether it's a predictive maintenance system deciding a costly repair is needed, an autonomous system navigating complex traffic situations, or maybe even an AI-powered hiring tool filtering resumes based on patterns it learned from past workforce data.
Okay.
How do we ensure these decisions are actually fair and unbiased? AI models are trained on data, and if that historical data reflects societal biases, which it often does, the AI will likely learn, perpetuate, and sometimes even amplify those biases in its decisions.
So the AI could be systematically unfair without anyone intending it to be.
That's a huge risk. And then there's the accountability question. Who is responsible if an AI's decision leads to a negative outcome? Especially if the decision-making process is incredibly complex or opaque, what people sometimes call black box AI, where even the creators don't fully understand how it reached the specific conclusion.
Fairness, bias, accountability in AI decisions. These are incredibly challenging ethical issues that society is really just beginning to grapple with seriously.
They are indeed. And the source emphasizes the need for organizations to not just react passively to current regulations, but to proactively try and anticipate future ones and prepare for ongoing compliance as the field evolves.
But how can a company realistically anticipate regulations that haven't even been written yet? That sounds like fortune telling.
Well, it's not about having a crystal ball, but about adopting a proactive stance and staying engaged. Organizations need to stay informed about policy discussions, proposed legislation, and regulatory trends globally in their sectors. They should aim to build flexibility into their AI IoT architectures so systems can be adapted more easily to meet new requirements as they emerge.
Build for change.
Exactly. And crucially, they should prioritize ethical design principles right from the very outset of development, incorporating things like privacy by design, security by design, and fairness considerations into the core architecture and development process itself, rather than trying to retrofit them later when a regulator comes knocking.
Be proactive, not reactive.
Right. And engaging with policymakers, participating in industry standards bodies, contributing to the public dialogue about responsible AI and IoT development, these are also vital proactive steps companies can take.
What's really fascinating here, and maybe a bit concerning, is that inherent tension between the incredibly rapid pace of technological innovation in AI and IoT and the much, much slower process of regulatory development and societal consensus building around the ethical norms we want to uphold.
That tension is precisely the challenge we face as a society right now. Technology often moves faster than our ability to fully understand and manage its implications. And this raises a really important question for all of us, not just technologists or policymakers. As AI and IoT become increasingly integrated into the very fabric of our lives and our industries, how do we collectively ensure that this powerful technological revolution is guided in a way that maximizes its benefits for society, while proactively mitigating the potential harms and ensuring it aligns with our deeply held values of privacy, fairness, safety, and human dignity?
It really requires ongoing vigilance, doesn't it? An open dialogue, collaboration across technologists, businesses, governments, ethicists, and citizens alike to consciously shape a future where AI and IoT serve humanity responsibly.
It absolutely has to be a shared responsibility to shape that future. We can't just let it happen passively.
Wow, that was a comprehensive deep dive. We've journeyed all the way from the foundational convergence of AI and IoT, understanding how they combine to create truly intelligent, connected systems.
Yeah, and we explored their transformative impact across such diverse applications, from enabling that really precise predictive maintenance that saves vast resources,
To personalizing our smart homes in ways that seem like science fiction just years ago.
and revolutionizing entire industrial sectors through the power of IoT.
And we've also highlighted the critical infrastructure and operational necessities that underpin all of this, the crucial need for robust data management and pervasive cybersecurity.
And the enabling power of edge computing for delivering those real-time, scalable solutions where they're needed most.
We also dug into the indispensable human element, the pressing need to cultivate a skilled workforce and foster an organizational culture that can actually embrace and leverage these powerful technologies effectively.
And finally, we confronted the vital, broader context, that evolving landscape of regulations and the profound ethical considerations that simply must guide the development and deployment of AI/IoT if we want to ensure it benefits society responsibly.
So for the developers and engineers listening, understanding these advancements is really key to building the next generation of truly intelligent, efficient, and importantly, secure connected devices and systems.
Absolutely. And for technical management and business decision makers, grasping the benefits, the challenges, and the underlying requirements provides that necessary foundation for strategic planning, for making informed investment decisions, and for successfully leading your organizations through this major technological transformation.
Ultimately, we hope this deep dive provides you, our listener, with a comprehensive understanding of a technological convergence that isn't just driving incremental operational improvements, but is genuinely opening up entirely new possibilities across nearly every sector imaginable.
It's a really exciting and challenging time.
It really is. So as AI and IoT become ever more woven into the fabric of our daily lives, our industries, and the infrastructure that underpins modern society, here is a final thought for you to consider. Given the incredible power and pervasiveness of these technologies, what specific steps do you believe are most important for individuals, organizations, or perhaps governments to take right now to ensure that this AI/IoT revolution unfolds in a way that is safe, equitable, and genuinely serves the well-being of all?
That's a really important question worth pondering as we all continue to build and live in this increasingly connected, intelligent future.